and welcome to Math with Bill. In this next set of videos, you're going to be looking at derivatives of the trig or trigonometric functions. Trig functions. As a quick review, we have sine, cosine, and tangent, which are the major three, and then the other three are the reciprocals of these, which are cosecant, secant, and cotangent. We're going to be looking at all six, but in this first video, we're going to focus on the sine function. So, we're going to set up a difference quotient. For those of you in calculus, this shouldn't be anything new, but what we're doing here is the difference quotient. So we're going to take the limit as theta approaches 0 of sine of theta plus delta theta minus sine theta, all divided by delta theta. Okay, so it's the limit here as delta theta goes to 0, and that's your basic difference quotient, which is the basis of all of our derivatives. Okay, so we're doing a longhand form here. To get an idea for what's happening, let's go through the trig of the sine of a sum, and that is sine cosine, then cosine sine. So it's going to be sine of the first. So what we're doing right now is expanding this piece, and what that's going to give us is sine of the first, which is sine theta, times cosine of the second, delta theta, plus cosine of the first, so cosine theta, times sine of delta theta, minus sine theta. Okay, and that's just copying this last piece over. Okay, so all of this is now under our delta theta. At this point, what I need you to do is look at this and try to determine what terms we might have in common. Hopefully you've picked up that we have the term sine theta in both the first term and the last term. What we're going to do is gather those two together and then be able to pull out a common factor. Okay, so rewriting this, I now have sine theta cosine delta theta minus the sine theta, and then plus cosine theta sine delta theta. Okay, so the reason this whole thing is important or valuable to us is now that we can now factor out our common term. So we get a common term of sine theta times the quantity of cosine theta minus 1, all divided by delta theta. Okay. The second part here then becomes plus cosine theta times sine theta, or sine delta theta, all divided by delta theta. Because this is a multiplication, okay, because each of these terms now has a multiplier, I'm going to separate this out and make it a product of two fractions, sine theta over 1, and then cosine of delta theta minus 1 divided by delta theta, okay, plus cosine theta over 1 times this sine of delta theta divided by delta theta. The reason I do that is the only two terms that can change are the ones involving delta theta, because it is this piece right here that we want to take our limit of. Okay, so this piece here is now more or less a constant. because this, as well as our cosine theta, will not vary as delta theta varies. Okay, so let's keep that in mind. Now, we need to explore this whole idea of cosine delta theta minus 1 divided by delta theta, because each of these is a 0 divided by 0 if we just apply the limit. So what we need to do is, I want you to look next at the video that explains why this cosine delta theta minus 1 divided by delta theta, the limit of this is actually 0. Okay, so I'll have a video on this. You should look at it. Okay, so it'll be 0 times sine theta plus, and the limit here of the sine of delta theta as compared to the change in theta, actually the limit here is 1. So it's cosine times 1. So sine times 0 just becomes 0 plus cosine of theta times 1. So our limit is cosine of theta. Long story short, the derivative with respect to theta of sine theta is cosine theta. If it's sine of x, it would be d dx of sine x is equal to cosine x. In summary, looking here, the derivative of sine is cosine in the next couple of videos. First, you should check out this limit and how that comes to be, as well as our other 5 trig functions.